Good afternoon. Hello, everyone. I'm Seungjai. I'm head of the Data Analytics Center at Samsung SDS. And this is?
I'm Taeyeop, software engineer in Samsung SDS.
So we're going to talk about Brightest Studio on open source enterprise AI platform on your laptop. So basically, this is for if you are building business applications and if you want to add machine learning capability or AI capability into your business application. We are introducing a platform that you can easily develop your machine learning model. So we'll describe about it. We will start with the data analytics trend, what is Brightest Studio, and a demo. Taeyeop will lead this demo session. And finally, Brightics AI, the whole architecture. So let's start with the trend. So the KD Nuggets conducted a survey on top software for data science and machine learning. And they asked the data scientists. Data scientists are asked to answer about their software tools and AI platform they are using for their machine learning projects during the last 12 months. And what we can see here is that the average number of tools and software platforms they are using for their machine learning project is 7.0, which is slightly higher than 6.75 last year. So it means that data scientists are using different tools and platforms for different purposes. So one size fits all doesn't work in machine learning field. And you can see here, So Python and R are machine learning programming language. If you want a free form, then you use this one. And if you need an AI platform, machine learning platform, you use like RapidMiner, NIME, H2O, those kind of platform. You also need to be familiar with SQL, especially because if you are writing machine learning project using R and Python, and you need a case that you need to query the standard data form, then if you use SQL, your code size will be much, much more concise and compact. So these are the trend. And also another thing that you can notice is that TensorFlow and Keras, these deep learning frameworks are gaining popularity. That you also want to learn about this one, because if you know how to use TensorFlow and Keras, then when you try to build a machine learning model, you can first try regression and classification like a traditional machine learning model. And also you can try RNN and CNN together to get the best result. So for R and Python, for traditional machine learning, and PyTorch and TensorFlow and Keras for deep learning capability. You need to mix and match these software and tools. And the second trend is that visual analytics environment for citizen data scientists. So if you are a data scientist, then you are on your left side. You know how to do R and Python coding. Then if you attack the machine learning project, then you start writing your Python code here. But if you are domain experts, we call them citizen data scientists. If you are domain experts who has a domain knowledge in your field, for example, if you are a manufacturing process engineer, marketing campaign manager, or logistics experts, then you don't necessarily have this kind of a programming skill. Then you still want to apply AI to your task. In that case, this kind of a visual environment will be better, where you can drag and drop these functions and run it, and then interactively see these visual charts so that you can build your model here. If there's such a visual analytics tool, it will be very helpful for citizen data scientists. Next trend is acceleration in automated analytics. We also call it auto machine learning. So basically what data scientists do is once they build a model, their performance will be somewhere here. But this performance landscape can be unknown, and you want to achieve the global minima, like maybe here, but you may fall into local minima here. Then you can try again and again. So what data scientists normally do in a daily basis is doing this try and error again. So this is very tedious work. And what we want to do is we let the AI and machine learning do this kind of try and error for you. So you try, for example, there are parameters for certain machine learning functions. Then there can be numerous cases. And they try it. I mean, the machine learning or AI can try it multiple times, and it can find the best parameter, the best performing one, and remember this one and suggest to you. That's the one trend. And these are based on the feedback from the users of Brightics AI. Brightics AI is a Samsung SDS AI platform. So the users who are software developers, they say, we need more open source features. I mean, currently open source machine learning platforms are focused on building machine learning model efficiently. But once you build a model, there's a way that you can easily share with others and then export it to the operational side. So those kind of features are needed, and we need these kind of features included in the open source. And second one, the industry experts, here we also already called citizen data scientists. They are saying that they want to apply AI to their tasks without coding. And these college and graduate students who are actually under the Brightics Academy. Brightics Academy is our sponsored program that we provide our Brightics AI platform to the classes. And then these students are saying that they prefer open source because once the class is done, they want to use it. I mean, once the semester is done, they want to keep use it. Whereas if it's a commercial software, then there's a license limitation that you cannot use it after class. So for these cases, the open source is needed here. So based on this motivation and trends and the feedback from the users, we open source our Brightest Studio. So what it is, I mean, it has 6 features. One is workflow modeler for visualizing the modeling environment. Second is a user-defined function. This is for customization. You have your own machine learning function you want to add, then you don't have to wait until the open source release date. And you're not sure whether your specific needs will be reflected on the open source release. So in that case, you have your open source and then just add your user-defined function so that you can have a customized working environment. And ready-to-use features, for example, the connecting to the external input data sources and sharing and deploying your model, those things needs to be included in the library. And deep learning features. Currently, if you want to use deep learning framework, you need to be familiar with the Python coding to do some scripting there. But here we are providing the visualized deep learning environment. And also the 5th feature is the third-party interface that there's a deep learning and machine learning service on the public cloud. We provide an interface to that. And finally, it is an open source under Apache license version 2.0. So the first one, workflow modeler. What is workflow modeler? You can see on the top, this is the whole process, the machine learning process. So the first node indicates the load operation. So what this one does is reads data from the file, and then it does some pre-processing, filtering, and another pre-processing, which is splitting data. It splits the data into trained data set and test data set. And then once data set is split into it, then you can perform machine learning operation here. So from data load to the end, and the visualization, from end to end visualization of the whole process, you can see at the top. And you can have a snapshot of this process. Let's say we click this statistical summary node, then the node color changes to green. Then the bottom shows the property of this one. So the left shows the input of this function. So you can explore the data. Once you explore the data, you know what to do. Then select the columns and set the parameter and run it. And you can see the output on your right side. So other softwares, you usually see, you either see this workflow model, and then click the one node and see the input or output in a pop-up mode. But here is what is different is that input and output and the whole process is flattened in a single window, a single screen. And we think this one is much better environment for modeling the machine learning case. That if you see the input and output, if the output is not what you expected, you can change the parameter, and you can even change the function that you are applying to here, then until you get the expected output. Then you complete one node. And by incrementally completing each node, you can design the whole process. This is how you build a machine learning process here. So I said input data visualization. You can instantly execute the function. You can see the output in the same screen. And each node has a nested one. So if you double-click this one, it will show another workflow there. And when you drag and drop this node, there are functions here. And these are the list of functions that we are currently providing. And these functions, of course, it may not be sufficient for your use. We are adding more functions in each release. And so this will cover most of the case. But still, if you need your own specific use cases, I mean your own case, then there should be a way to add your user-defined function. So next one is for that. So if you have your own function, let's say this is your Python script you want to add into this open source, copy and paste to it, and then store it, and you can specify the name of your function. You can specify the input parameter. For example, if your number of inputs, and if each input is an integer format or double precision or floating, I mean single precision and so on. And then once you specify the input, then there's an import to UDF, user-defined function, and your script will be loaded here, and it will be shown in the palette here. So there must be functions that we are providing as an open source release, and there will be functions that you uploaded there so that you can have your customized environment. Next feature is a ready-to-use connection. So we provide library that for, if you want to read data from your CSV file in your local PC or your laptop, or if you want to have a connection to the relational database like IBM, DB2, Oracle, Postgre, and so on, you don't have to find the library to read that from that relational database, read the API, and write your own code, and then do some debugging. We already tested for you, so you can just call these functions. And we even have a library to access the data in the S3 in your AWS cloud. And these are useful features. And the next one is a deploy feature. In the first feature, we show how to build your model. Once your model is built, then you can deploy to the external device. That this is like the final model is as a Python script will be exported and encrypted so that it will not be stolen to others. And then you can run on your device, like laptop or mobile device or edge device if it has a Linux environment. And also, it provides the RESTful API that if you download this Brightest Studio and install it into the analytics server, this server can be either your private server or public cloud. You have an instance in your public cloud and install this Brightest Studio, and you build model here. Then what you want to do is you want to build this kind of business application, and you want to run some small machine learning case. Then, since you have built this model, what your business application does is execute the job and get the result. Of course, during this job execution, you constantly check. You can check the job status. Once it's done, you can request the report and get the result back, and you can visualize it in your, if your business application is running on your tablet or in a PC, this is how you build your business application. This model doesn't have to be embedded in your business application. It can be on a cloud or a remote server. You can access through this RESTful API. The fourth feature is a deep learning interface. So currently, what people do deep learning is through the deep learning framework. TensorFlow, Keras is the most popular one. Then you need to do some Python coding to specify this one. But we think when you do the deep learning experiment, what you really want to focus on is architecting the deep learning network architecture. Like how many layers in a deep learning network, where to insert the max pooling, where to insert the dropout layer, and how many hidden nodes per layer, those kind of things. Those kind of hyperparameter setting, that's where you want to focus on. So once you design your deep learning network, then it can, as a one single node, you can run it in our visual environment. And then once deep learning result is done, you can perform the post-processing using our machine learning capability, data processing capability. Or you can export this model into a Python script. Then you can run this Python script to your preferred deep learning framework, such as TensorFlow and Keras. So next one is similar but a little bit different. Like currently, if you are using the public cloud, like AWS, Amazon Azure, Google Cloud, they all provide machine learning and deep learning services. So if you want to use those services instead of using your own computing power, then what Brightest Studio can do is, here you can set, for example, AWS, if you want to use AWS SageMaker, here you can set, I want to have an instance, AWS instance in the west coast of California, west coast of US, and then I want to have 10 instances. After your specification is done, you can throw your training code image, and then it will run on the AWS server, and then the result is returned back to you. So we provide an easy interface to those kind of deep learning services by the current public cloud service providers. So this open source, you can download it from Brightics AI or GitHub website. Among features that I have described today, these are the release date. Today we are launching the 1.0. The visual modeling and 40 types of analytics functions, and the user-defined function that you can add, and library to connect to the external input data sources, and sharing your model with others using RESTful API. This is available as of now. Once you download from this website, this address. First quarter of next year, we will provide the visual model for deep learning, and deploying your model and interface to public cloud service will be second quarter. And the third quarter will provide the Python query engine. I think compared to other open sources, we have a different flavor, but I think the Python query engine will be a differentiator too, because when you do the Python coding, there's no direct way to query your data frame in Panda library. So we're going to provide a direct query access to your data frame. So I think this will be a really useful feature when it will be released in next year. So demo, what Taeyeop is going to show is that you will see in this demo how to create a model from the scratch and select the input data sources, build the model and run, and check the visualized chart and summary, and create a report and so on. So, okay, you can go.
I'll demonstrate how to use Brightest Studio. You can download the Brightest Studio from this Brightix Assistant portal or from GitHub as open source. And this is Brightix Studio. So first, you should create a project to create an analytics model. Okay. Hello, Brightix. Okay. If there is a model you've created before, you can just import it and use it. Look at this. Analytics model is in the form of flow, which would help you understand the entire data flow. And it's much easier to understand data flow than manipulating data only with Python or R code. And you can load data from various data sources. This is local. And not only from local files, but also from S3, AWS S3, and database such as Postgres, MariaDB, Oracle, and MySQL. And you can load the data easily if you just register your data source in this dialog. Okay, you can run this model with this run button. I'll show you. Yes. We provide various functions you need to analyze data. Okay, I'll show you. Some pre-process and statistics, transform, regression, classification, evaluation, etc. And you can use your Python script like this. I already created for this demo. You just write your Python code in here and run it. Then you can execute your Python script you already have. And I will introduce a feature called the UserDefined function. So click this Create UDF button. And this is a UDF generator. So you just type in to this label per function and check this. Then I already created this UDF for this demo. So let's see. So you just write your Python code and save it. We go back to workflow and import the UDF. Already download. Then I already imported, so you can use this UDF for this data flow. So you can share this code to other easily. And we provide various types of chart. So you just choose a chart type in chart setting. Then you can see the chart. Like this. And area chart or box plot like this. Okay, then I'm going to create a new simple model for sample data. It is energy uses data demo. First, I load the data to analyze the data. So energy uses and run. Look at this data. It has null value, so I need to replace this value to 0. Then replace number. So setting for this function. Then I replace the null values to 0, you can see. And I need some train data, so I will add a filter function. I will filter for year. Year 2016. Then I filter this data. And I will use XGB regression train for make a regression model. You know, XGB is extreme gradient boosting, which is popular amongst Kaggle users these days. And you just select columns and for label. You can see this summary view to understand the results. This is a simple model, and if you want to predict some value, you can also use predict function and data. Just connect and run it. Then you can see the value, prediction value, this model. So we want to see how well this model have fitted the data. Then you can add evaluate function, regression function, and choose label column and prediction column, and run it. You can see the results for this model. Okay, and I will show you some complex model for demo. And run it. I loaded the data from S3 and the database and merged join data with join function and pre-process with functions such as filter. This is a Python script, actually, and scale, pivot table, and replace missing number. We provide the k-means select function, which automatically selects the number of clusters in the clusters set you typed in, like this. Also, you can prediction, okay. And finally, we provide some feature report, so you can create a report in Brightest Studio. So add to normal state. Add to report this chart. Like this. Then you can see on the left side, you can see the chart in the report. And just click this, then the chart will be in report. Like this. And you can add a texture in the report. Like this. And you can export this report as a PDF file. So print PDF. Then you can export this report. Okay, let's keep it. Finally, you can export this analytics model to share with others or import to other systems. This is the end of the demo. Thank you.
Thank you, Taeyeop. So you've seen that there are some still terminologies that you need statistical machine learning background, like XGBoost, K-means, and so on. So our goal is to make it much, much simpler. That instead of XGBoost or K-means, we want to change it to like forecast or cluster, more like a plain English. Then it requires more AI and machine learning technique inside it, because instead of human data scientists specifying what to do, the AI and machine learning will try to find the best model based on each input data. Then it requires a lot of computation. So that will come. I mean, I think that will be the research topic that every open source machine learning platform is trying to tackle. So it's going to be a very interesting thing to see how much will be automated here. So since I have only 2 minutes, I will wrap up here. So this is the Brightics AI platform. This is the whole Brightics AI platform. The front end is what you just saw. We call it visual analytics, that you can just visually perform data analytics modeling here. And the back end, it has two parts. One is a Spark agent part, Spark architecture. The other is a Python architecture. So what Spark architecture does is, this is for the big data handling, where Hadoop is for the distributed data storage, and Spark is for distributed computing. So if you need to handle a couple billions of rows of data, or your data set size is more than terabytes of data, then you need to have a distributed servers to handle this large data set. But if your data is small, or sampled data, or if you have a big single server that has a large memory, then just this Python backend engine will suffice. So what we are doing here is that for a single server implementation, these blue ones, light blue ones, we are open sourcing it. So these blue areas are what you just saw today as an open source. We're going to expand more white areas into a blue one, so that we can have a more blue box as an open source here. This one is not just a recently written open source code. It has been more than 5 years we have worked on it. We have secured 70 references in Samsung affiliate companies, mostly manufacturing and marketing area. Logistics, we have a demand sensitive prediction area that, and we'll show just a 1 minute video clip, even though we almost finished, but last video clip we're going to show you here.
Demand forecasting is paramount for SCM and logistics operations. Inaccurate forecasts result in excess inventory or a shortage of inventory, which leads to a decline in the corporate's competitiveness and financial burdens. Even today, many companies still rely on their past experiences and intuition. or they are predominantly making extensive forecasting based on regions and product lines, and have difficulty forecasting detailed demand for each store and by product unit. Samsung Electronics Austria had similar concerns before the introduction of Samsung SDS's Cello demand sensing.
Before implementing the solution was more complicated than now because we were not really sure at the end about how many units, how much will be our sales in the future. We had different factors that influence the future sales, and we were not sure about the impact of these factors in our sales.
Accurate demand forecasting requires modeling to analyze the numerous factors that affect sales and their complex correlation. The lack of such analytics model revealed the limitation of existing demand forecasting. Cello demand sensing, on the other hand, leverages the machine learning technique of Brightics AI to analyze a great deal of data, creating its own optimal analytical model. Cello demand sensing, with its Brightics AI-based analytics model, enables companies to maximize sales opportunities, while avoiding excess inventory to reduce logistics expenses, through more accurate and detailed demand forecasting.
So I just showed this video clip to illustrate that using this Brightest Studio, you can build this kind of a forecasting model, and we actually deployed it into our European branch here. So that's the end of our presentation. So if you have a question. Thank you. Okay, so if you don't have a question, we'll stay here for 10, 15 more minutes. And okay.
On the marketing examples,
yes.
Besides the video, do you have other examples documented on a Samsung SDS website?
Yes, we are, if you go to our website, there's a list of projects we actually tried and machine learning models. We call it pre-built models, and we provide the template so that you can use it start from there. So, Google Samsung SDS Brightics. It will work.
Like this. Use case.
Yeah. If not, okay. Thank you, everybody. Thanks.